Today we're going to look at solutions to two-variable linear inequalities. So we have two methods that we're going to use to figure out if an ordered pair is a solution to a linear inequality. With the first method, we're going to substitute in our numbers for our variables in the inequality. And when we do that, if we get a true statement, then that ordered pair is a solution. If our statement's not true, if it's false, then it's not a solution. So example 1 says, is -5, -2 a solution to the inequality 2x minus 5, 2x minus y is less than 5. So our x is -5 and our y is -2. So we're going to plug it into this inequality here. So we're going to bring down the 2. Well, we just said our x value is -5. So 2 times -5 minus our y value we said is -2, and bring down that less than 5. Okay, and then we're going to simplify. So 2 times -5 is -10. Then we're going to subtract -2, bring down that less than 5. -10 minus -2, well, that's the same thing as -10 plus 2, which is -8. We'll bring down that less than 5. Well, -8 is less than 5. That is a true statement. So that means that -5, -2 is a solution to our inequality. So example 2 says, is 5(1) a solution to the inequality x minus 4y is less than 1? So 5 is our x, 1 is our y. So we're going to plug it into your inequality over here. So x is 5 minus 4 times our y value is 1. Bring down that less than 1. So we have 5 minus 4 is less than 1. 5 minus 4 is 1. 1 less than 1. Well, that's not true. 1's not less than 1. So 5(1) is not a solution. So for our second method, we're actually going to use the graph, which is what we've been doing earlier in the week. So we're going to graph our inequality just like we've been doing. If the ordered pair lies on this dotted line, it's on the dotted line, that's not a solution. If it's on the solid line, that is a solution. And when you look at the shaded area, so let's say we're shading over here and our point falls in that shaded area, then that is a solution. If we have one where we're looking at our point and it's not in the shaded area, let's say it was somewhere over here, not in the shaded, that's not a solution. Okay, so let's look at these examples. So we have, is -3, 0 a solution to the inequality y is greater than or equal to x plus 2? So this is our inequality we're looking at. So it's already solved for y. So we can say our slope is 1. We'll put that over 1 since it's not a whole number. And our y-intercept would be 2. Okay, and then we're going to say, since we have that solid line underneath the inequality, we're going to have a solid line, and then since it's greater than, that means we're going to shade above. So we'll start with our y-intercept, which is 2, and then our slope is 1 over 1, so up 1 and right 1, up 1 and right 1, up 1 and right 1, or you could go down and left to get your other points. And we said it's going to be a solid line, so we'll go all the way through, extend it. And we had greater than, so we're going to shade above. So all this stuff above the line. So now the question is -3, 0 a solution? So let's plot that point. -3, 0 is right there. And notice how it falls in the green shaded? So that means yes, that is a solution. So then let's look at the second one here. So is 2, 0 a solution? So let's plot that point. So write 2 at 0. Notice that yellow point is not in the green shaded area, so that is not a solution.